Alrighty, so last time we talked about parent functions and we simply graphed those parent functions. Today we are going to be talking about horizontal shifts. Okay, and horizontal shifts literally means we are moving the points on the graph to the right or left. Okay, we're moving them horizontally. Alrighty, okay, so let's go ahead and graph these guys. It says graph the original function or the parent function and then graph the horizontal shift. So I actually want to label this first guy. That is our parent function. I'm sorry, it's so shaky. Okay, perfect. So that is our parent function. Last time we talked about graphing these guys, okay? So when I am graphing these guys, we use our t-chart. Okay, we choose values to plug in for x, and then we plug them into our function, we get y out. So I'm just focusing on the parent function right now. We did this last time, but let's go ahead and do it again. So if I'm gonna choose 5 numbers to plug in for x, see what we get for y, okay? Well, if I am choosing -2 to plug in for my x here, that would give me y equals -2 squared, which I know is going to give me a +4. Okay, again, if I were to plug in -1 squared is going to give me +1. Okay, we know that 0 squared, which is 0, 1 squared is +1, and 2 squared is +4. Okay, so those have become my parent function points. Okay, so again, these are coordinate points on your graph. These are the coordinate points of my parent function. Okay, so let's go ahead and put them on our graph. I have -2, +4. I have -1, +1. I have 0, 0, +1, +1, and 2, +4. Okay, so the green is my parent function. We graphed this last time. But now it wants us to graph this function right here. Okay, this function, the second one, y equals parentheses x minus 3 squared, has been transformed, okay? Or think moved. Okay, so whenever you see something inside the parentheses like this, okay, so we have this -3 that's been added to this original function. Okay, this means we're moving right and left anytime you see inside the parentheses like that. Okay, so just looking at -3, you might think, oh, okay, that means I'm going to move to the left 3 because it's -3. This is actually the opposite. This guy means we are moving to the right 3. That -3 means we are moving to the right. Okay, and from here, I actually don't have to plug in any new points. I can just take each of these points and move them to the right 3. Okay, so we'll start with this guy. 1, 2, 3. Okay, this guy, 1, 2, 3. This guy, 1, 2, 3. That guy, 1, 2, 3. And finally that guy, 1, 2, 3. Okay, so now my red parabola, from the green to the red, we see that it's been moved to the right 3. Okay, and that's really all we're doing today, is taking the original parent function and then deciphering how it's being moved. Okay, we talked about whenever you see inside some parentheses like this, inside, think left or right. You're going to want to originally think left 3 because it's negative. It's the opposite when it's inside, it is to the right 3. Okay, so let's go ahead and try that again. Okay, so I have my number 2. My original parent function here is square root of x. So I'm just gonna focus on my parent function when doing my t-chart. Again, we did this last time. Okay, so the thing we want to remember about the square root function is that I want to choose numbers to plug in that will actually give me nice numbers out. So numbers that I can actually square root. So 0 I could square root, 1 is a perfect square, and 4 is a perfect square. Okay, so now when I plug these in, y equals the square root of 0, because I'm plugging in 0 for x, is just 0. Next one, y equals the square root of 1, which is 1. And then we have y equals the square root of 4, which is 2. Okay, so these 3 coordinate points are plenty to graph. So let's go ahead and put them on our graph. So I have 0, 0, 1, 1, 4, 2. Okay, so here's our original parent function right there. Remember, we never go into the negatives because you cannot square root a negative, so that's why it just starts at 0 and goes from there. Okay, now we need to decipher based on our transformed function or moved function how it's moved. So we still see that it's inside the square root, same thing as inside the parentheses over here. Okay, which means moving left or right. Okay, well, plus 2. Again, you might think, oh, plus is to the right 2. But remember, it's opposite. So this means it's moving to the left 2. Okay, so all we have to do from here is now take each of these 3 points that we found and move them to the left 2. So my first point, 1, 2. Second one, 1, 2. Third one, 1, 2. And now there's our transformed function. It's been moved to the left 2. And there we go. We graphed the original parent function and the transformed function with the horizontal shift is what we call it. All right, number 3. Okay, so this guy is an absolute value. We talked about this parent function last time, so let's go ahead and do our t-chart just for the parent function. Okay, so I'm going to choose the same 5 points that we usually use, a couple negatives, 0, and a couple positives. Okay, so now I'm going to go ahead and plug these in to find my parent function. So I know that the absolute value of -2, or in other words, think how far from 0 is -2? Well, it's 2 spaces, so +2. Okay, and same thing, we have the absolute value of -1. Well, that's 1 space from 0, so +1. Okay, then once we go into positives, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Okay, so here are our original parent function points, which are going to be super helpful for the rest of this unit. So we'll go ahead and graph them: -2, +2, -1, +1, 0, 0, +1, +1, +2, +2. Okay, and then we know that an absolute value, it's more of a V shape like that. So there is our parent function. Okay, now we need to look at our horizontal shift. Okay, so I have a 4 here, so I know that it's either moving to the left or right 4 units because it is inside those absolute values, which act like parentheses. Okay, well, +4, again, you might think, oh, +4, it's to the right 4. Remember, it's the opposite when it's inside. So +4 is going to move to the left 4. Okay, and from here, pretty simple. We just take all 5 of those points, move them to the left 4. So 1, 2, 3, 4. Next, 1, 2, 3, 4. Next, 1, 2, 3, 4. Next, 1, 2, 3, 4. And my last one, 1, 2, 3, 4. And there is my transformed function, the horizontal shift. Each of those points were moved to the left 4. Awesome. Okay, let's do our next one. So this guy, we see our original parent function is x cubed. So this tells me this is a cubic function. So let's go ahead and choose our values. We'll choose the same 5. Okay. So now I'm going to plug them into my original parent function to see what I get. Y equals, first is -2 cubed. Okay, now if you have a calculator, you can just plug this in, but be very careful. Make sure you plug in the parentheses, or else that cubed will just attach to the 2. Okay, well remember, this is like saying -2 times -2 times -2. Negative times a negative is going to give me a +4 times another -2, -8. So I get -8 there. Okay, same type of thing for -1. So when I take -1 cubed, this is really saying -1 times -1 times -1. Negative times a negative gives me -1, or +1, excuse me. Negative times a negative gives me +1 times another negative. Well, that's going to give me -1. Okay, well then the rest are pretty simple. 0 cubed is still just 0. 1 cubed, 1 times 1 times 1, still just 1. And then 2 cubed, I want to write this one down because a lot of people confuse 2 cubed with 2 times 3. Okay, that would be 6. Remember, this is saying 2 times 2, which is 4, times another 2, which is 8. So 2 cubed is 8. Okay, so now that I have all my parent function points, let's go ahead and put them on our graph. Okay, so I have -2 down to -8 right there. I have -1, -1. I have 0, 0, +1, +1, and then 2 up to 8. Okay, so I really like that we added these two, or else we might just think that's a straight line there, but it's really this skinny S-looking shape for our cubic. Okay, so that was our parent function. Now we need to decide and decipher how it's being moved, okay? Well, again, it's inside the parentheses. So we know left or right. -2, which we originally might think, oh, -2, we're going to the left. Remember, it's the opposite. So this guy is right 2. Okay, so now we're going to take each of these points on our graph and just move them to the right 2 spaces. 1, 2. Next one, 1, 2. Next one, 1, 2. Next one, 1, 2. My last one, 1, 2. And there is our transformed function. Each of those points were moved to the right 2. Awesome. Okay, so on these guys, we graphed the parent function and then we graphed the transformed function based on what the equation said. The next few problems, we're actually going to write the equation given the transformation. Okay, so the very first thing we can always add, or at least start with, okay, let me just zoom in a little bit so we can read it. Okay, so the very first thing we can always start with is our y equals. So that's going to be in our final answer, y equals. You can put y equals on all of these guys, okay? So first of all, a quadratic function. Okay, well, a quadratic, if you remember from last time, is one where we have x squared. In fact, let me do different colors so we can identify. Okay, so quadratic function is where we get the x squared from. Okay, now it says it's been shifted to the right 3 units. Okay, so remember, in right and left always means there's some parentheses. Okay, so this means my x is going to go right here. My squared gets moved to the outside because now we have our shift. And now we need to decide, okay, it's right 3 units. Okay, well, again, with the right, we might think, oh, it's going into the positives. But remember, it's the opposite. Okay, so whenever you see right, think negative. So now -3 units. Okay, which let's go ahead and just put that as our final equation. So I have x minus 3 squared. This is a quadratic function that's been shifted to the right 3 units. And there is our equation based on the transformation given. Beautiful. Okay. All right, so let's start with our y equals. That's going to be in our final answer. Okay, but now let's look at what it's telling us. So I have an absolute value function, absolute value, which is this guy, my absolute values, that's been shifted to the left 2 units. Okay, well, left means on the inside. Okay, so give yourself some space to show your shift. And now you have left 2 units. Okay, well again, thinking left, you might think, oh, it's negative, it's going into the negatives. But think opposite, so plus 2. So that means our final equation, just copy it down here, the absolute value of x plus 2. Great job. Okay, let's keep going. Next one. Okay, so we can always just write our y equals. That's going to be in our final answer. So here we have a square root function, which is that guy, square root. And it's telling me it's being shifted to the left 4 units. Okay, so this one doesn't have parentheses. So whenever it's the left or right, think inside of something. This square root acts the same as the parentheses. So now it just becomes bigger to give yourself the space for the shift. Okay, and it now says left 4 units. Okay, so again, whenever you see left, think plus. It's the opposite. Okay, so our final answer here, our equation, x plus 4. Beautiful. Okay, last one where we're writing an equation. Let's do our y equals for our final answer. Okay, now let's just go through it piece by piece. A cubic function. Cubic means x cubed. Okay, and it's been shifted to the right 5 units. So right and left, there's always parentheses. So now my x is inside the parentheses. My cubed is on the outside, leaving space for your shift. Okay, and this time it's right 5. Okay, don't get confused. Right, you might want to think plus, but it's the opposite, so minus 5. So our final answer is y equals x minus 5 cubed. A cubic function that has been shifted to the right 5 units. Beautiful. Okay, the last thing you're going to do on your assignment is you're simply going to transform like a shape that's given to you on a coordinate plane. Okay, and this is super simple, okay? Oh my good gosh. That is not funny. Let me fix that. Shifted. Okay, shifted 6 units to the right. Oh my gosh, it's on number 10 too. Shifted. Okay, so number 9. When it says shifted 6 units to the right, all we have to do is take each one of these coordinate points on this shape and move them 6 units to the right. Okay, that's all we're doing here. So this first one, 1, 2, 3, 4, 5, 6. Next one, 1, 2, 3, 4, 5, 6. And my last one, 1, 2, 3, 4, 5, 6. Okay, and that's what you're going to do on your assignment. You're literally just shifting the shape that it gives you, transforming it, moving it. Okay, let's go to number 10. Shifted 3 units to the left. Okay, so again, each one of these points, 1, 2, 3, 1, 2, 3. Just make sure you're going in the right direction. 1, 2, 3, and 1, 2, 3. Connect them. And there we go. Awesome job.